So guys, we had just written our hello world example which demonstrate multi-threading. Now using a hello world example, we will going to discuss some aspects of the multi-threading that include argument passing, race conditions, thread termination, and then we will discuss that what is the impact on multi-threaded program when main function or main thread dies. So starting with the point number 1, as I've already explained that whenever you pass an argument to the pthread underscore create API, that is the last argument of this pthread underscore create API, that memory should be static memory or a memory on the heap, right? It should never be a memory on the stack or local variable. So I have already discussed this point in pretty much detail when we were discussing the implementation of our hello world example. Let us switch to the point number 2, that is the race condition on thread creation. So this point means that during new thread creation, a race condition happens. So to illustrate this point, as you can see on the screen, I have a thread T1 and this is the fork point. The thread T1 creates another thread T2, right? Now let us suppose that immediately after the fork point, there is an instruction I1 which is present in the execution flow of the thread T1, right? And immediately after the fork point, there is an instruction I2 which is the first instruction in the execution flow of the thread T2, right? So let's say for example, the instruction I1 is nothing but it simply says print T1, right? And the instruction I2, for instance, it simply says print T2, right? So now with this example in place, what exactly is the race condition? So here the race condition means that immediately after the fork point F, you cannot say whether it will going to be the instruction I1 which will going to be execute first, or is it the instruction I2 which will going to be execute first. You cannot say whether I1 will execute before I2 or I2 will execute before I1. It is not in the programmer's hand. So during writing multi-threaded applications, you as a developer don't have to assume that it is always the instruction I1 or I2 which will going to execute first. Any instruction that is I1 or I2 can precede the other. It all depends whether your operating system schedules thread T1 first or thread T2 first, right? If the operating system schedules thread T1 first on the CPU, then it is the instruction I1 which will going to execute first. But in case if your operating system schedules the thread T2 on the CPU after the fork point, then it is the instruction I2 which will going to execute first. So this kind of indeterminism that is introduced right after the fork point is called race condition. Race condition here refers to that you cannot say that which instruction I1 or I2 will going to execute first. However, it's a different thing that in 99.9% chances are there that it is the instruction I1 which will going to execute first. The reason is that the thread T1 is already allocated the CPU at the fork point, right? And there is very less probability that your operating system will snatch away the CPU from the thread T1 and allocate the CPU to the newborn thread T2, right? The probability of happening of this is very less, but it is there, right? So while writing multi-threaded programs, as a developer, you cannot assume any fixed order of execution between instruction I1 and I2. This refers to as race condition on thread creation.